Guys, thanks for coming. This is a class on the Cisco STA1520 Tuning Adapter. It's really designed as a lunch and learn, so we'll take questions as we go and go through the slide presentation here and show some examples. So the goals of this course are to understand the purpose of the Cisco STA1520 Tuning Adapter, understand the interface between the tuning adapter and the UDCP, which is typically a TiVo. UDCP is Cable Lab speak for Unidirectional Digital Cable Product. And then the final goal is to understand the tuning adapter diagnostic screens. And we're looking at that. Those can be seen from a web browser or a PTEA message, then Command 2000 as well. Course flow is just very simple. One day, think of about an hour. It's, like I said, really designed to fit in a lunch and learn. So we stated the objectives, and we're just going to go through this presentation and some examples. So the STA1520 tuning adapter, it looks like an RG100 box, but it has significant modifications. It is a next-generation platform software box, so that's why you have to use that send PTEA message before you can enable your Command 2000 diags. One of the main difficulties when working with the tuning adapter is it doesn't have any audio or video outputs. So even if you had a TV to connect it to, you can't access any video ports because they're covered up by the shielding surrounding the USB interface. Engineering calls that shielding the CAN. It's very obvious. It's silvery. It's at the back, rectangular shaped box. So even though it's designed off of the standard RNG100 chassis or case, it doesn't have any audio and video ports. Even if it did, they probably would not be enabled in the software. There is no communication between the tuning adapter and the TiVo over the RF connection. So there's a cable in on the back of the tuning adapter. That's what the adapter needs to get its SI and its SAN tables and commute with the SDV server. There's an RF bypass next to that RF or cable in, and you can connect a short length cable between the tuning adapter and the TiVo, and that would go on the TiVo's cable in. But that's only video in, from the cable signal to the TiVo. The way that the TiVo communicates back to the adapter is over a USB 2.0 cable. So that's the other connection we typically have. And what you have there, as you can see in that fourth bullet point, I'm going to get into how this all works. You have resolve tuning response, channel table request, channel table response, table update, and there's some other things that are in the spec. But all that's really transparent to us, but that's what's going on. Conceptually, we'll go to that. Another thing that's unique about the adapter is it really just has a single LED on the front panel. So normal operation, it'll be solid green. If something not right, in the documentation, in the final bullet point, it's called staging the tuning adapter. The LED blinking patterns are documented. So, in operation, you should just see a solid green light. And to get that, you might have to hit the little power on button on the front, but that should be it. So here are a couple of acronyms here. TA stands for tuning adapter. R stands for tuning resolver. That was the original name of the tuning adapter. So the spec by Cable Labs that specifies the interface between the tuning adapter and the UDCP, which is almost always a TiVo. It's the spec called Tuning Resolver Interface Specification. So basically just know that TA and TR can be interchangeable at any time when you're talking about this product. T is that Cable Labs speak for the unidirectional digital cable product. But you've never seen it not be a TiVo, but I think I've heard of a case where a guy had like a quad QAM card in a PC, in a tablet PC. But I'm not sure how that's really supported. But it can be something besides a TiVo product. And then, of course, the USB cable between the tuning adapter and the TiVo. I'm just going to call it a TiVo for simplicity, and that's the only way that the TiVo can communicate with the tuning adapter. This is a couple links here. The Tuning Resolver Interface Specification. And these all Cable Labs specs are a moving target. So at the time I first developed some of this material, we were on, at least on their website at cablelabs.com, from spec I03. And then I went back, I was planning to modify some of these slides, and they had published interim spec I04. Basically, there's probably little changes between those. We're going to look at one section from that document. It's going to be a conceptual operational diagram. That's it right here. So the UDCP is the TiVo. R is our tuning adapter. So what you have is, for code has no idea if a channel is switched or not. So every time you change channels on your TiVo remote, it has to make a tuning resolve request to the adapter. So that goes over the USB cable, tuning resolve request. Adapter, if it's a switch channel, it'll communicate with the SD server, which for that now is the USRM. But generally speaking, it's called an SDV server. So once, regardless of whether or not the tuning adapter has to communicate with the SDV server, it'll stack a tuning resolve request. And then you can see that this, you see this tune, and the arrow kind of turns back on itself. For the example of a switch channel in a service group, the frequency can move around by the definition of a switch channel. So one might be on frequency F1, and then the next day be on frequency F2. So TiVo would be tuned to the new frequency that was given in the tuning resolve response from the tuning adapter, and then the TiVo sends a tuning resolve combination to the tuning adapter. That's basically all the tuning adapter does, is resolve tuning requests for TiVo. Now, you might think that it could be used for any two-way communications. It can't be used for any two-way communications. It can be used to provide two-way communications to an SDV server only. That is the only thing that the tuning adapter interface or tuning resolver interface specification covers. So you couldn't, for example, use a tuning adapter and write a VOD app for it and make VOD work on a TiVo. That's the way the spec works. The tuning adapter, despite that it was a product that was developed after 707 card mandate by the FCC, the tuning adapter doesn't have a cable card in it. It, in fact, has embedded security. it's like a legacy box in that respect. The TiVo, which I've labeled in red, and this diagram that's out of the tuning resolver interface specification, the TiVo one with the cable card in it. So that's a distinction to be made. So if you're authorizing the tuning adapter, you're not messing with the cable card MAC address. You're going to need that. Authorizing service, like say some subscription service like HBO, TiVo, that would be putting the HBO package on the cable card in the TiVo, not on the tuning adapter. Because in fact, the adapter only needs two packages: the package and the SDV package. Some sites don't use either of those, and some sites use both. So, think about how a cable card gets its channel map. It gets it from podchanfile.tbl BFIS. Those are usually one problem. As soon as you take that TiVo and connect it to a tuning adapter, it's not going to use PodChan, and it's not going to get its channel map from the cable card. So there are ways that this is done. One is the native SARA way. We have fewer and fewer SARA sites, but this is how it's done in the traditional Cisco way. So if there's a SARA application server, the tables are sent from the SARA application server to the DNCS, and then are ordered by SA Manager over QPSK. So basically what this diagram is showing is that the DNCS, in conjunction with the SARA app server, are going to send SI and tables to the tuning adapter. Then the adapter will send a defined channel table over to the TiVo. Once that channel map is over on the TiVo will be able to use the tune resolve request to figure out or request the frequency and MPEG program number from the tuning adapter for every single channel change. And then also you see here that the tuning adapter communicates with an SDV server. They called it an SDV session and resource manager in this diagram, but we just generally call it the SDV server, or probably common for us, just call it a USRM. So, the absence of the SARA app server, which is seemingly the case, SARA doesn't run. So the tables have to come from somewhere else. Now, the SARA is a box, so if SA Manager is turned off, how to get the tuning tables? What happens is that a third-party app server, like as an application server, will publish a TR config file on BFIS, and that's usually one per hub. And but you could also use a default channel map if you wanted to. So it's the TR config file. Again, when you see TR, just think TA and TR are interchangeable. And the thing about the TR config file is that it's the responsibility of the third-party vendor. For example, AD with their Maestro application server. So here's basically the slide that I have for the the TR-config file. So the actual BFIS path is it's moconfig/sdv, then the hub ID, and then the actual file is trconfig.tbl. And that the absolute path of that BFIS file would link to can vary with how they build their cabinets on BFIS. We've seen DS, DBS files, BFIS, DNCS, MSO config/SDV, hub trconfig.tbl, which matches the BFIS UL. Or we've also seen it at some sites. Home, DNCS, intro, MSO config, SDV, hub ID, config.tbl. So that indicates that there's a whole ways that these third parties have set it up. They would have to tell you. You could perhaps do a search on the DNCS for trconfig star and see where they all are. And then, if they've added a channel and a new channel and adapters aren't getting it, then probably there's a problem with the config file, and they'll have to update that on their MAS server and republish it on BFIS. But you have to help along with that, point them in the right direction. That config file is totally the responsibility of the third-party vendor, like AD for the Maestro application server. There's a lab tool that Cisco has called Make TR-config, but it's not something that we could ever use to generate TR-config files for a site because it's not scalable. If you closely at one of those earlier slides, see that even in the Sarah solution, config file was optional. Well, we chose not to ever implement a TR-config file on this application server. We just use SAM. Even though the spec allows for it, it was null, and we didn't implement it. So if someone says, well, I heard you have a make TR-config tool, it's not something that we could do. It's not scalable. They have to talk to ATG or Rovi or whoever has their app server. I found out from David Lutz in development that there's no tool to parse the TR-config file. So it's a binary file. All we see is if it's there on BFIS, we can see the time it was created. If we created, channel, on Tuesday and the timestamp was last Friday, then that our config file probably needs to be updated. But the way to parse it and see the tuning information in there, it would have been nice if engineering had built a tool like that, but they never did. So, tuning adapter packages and security. The SO tuning adapter has embedded security. The cable card goes in the TiVo. So the cable card goes in the TiVo and not the TA. So the only thing you need to authorize a TA, the only packages you need are the brick package and the SDV package, assuming the site uses both of those. The content packages will go on the cable card in the TiVo. So HBO, for example, Cinemax, what subscription packages they have. The tuning adapter either needs SAM or a TR-config file. There are a couple of entries that can put in the SAM GUI. So _SASD is the one that you've probably seen. It's require SDV to authorize SARA boxes to use SD services. There's a EID after that. It'll say SASD URL semicolon EID equals X. That's just a pretty standard SAM URL. There's another one which you probably never see used anymore, underscore TASD, but it is in the documentation on the tuning adapter. Just go back and say TASD stands for Scientific Atlanta Switch Digital. TASD stands for Tuning Adapter Switch Digital. This TASD, was used by original load on boot application for SDV. It was called bodclient.ptv. So basically what would happen is if you use underscore SASD, you could get the SD client SARA authorized, and then Big Band's load on boot client would be loaded in memory, so you would have two SDV clients, and that's not desirable, obviously. So that's why underscore TASD was implemented, but shouldn't see it anymore. So if both of these, underscore SASD and underscore TASD, are present in the SAM table, the tuning adapter will just use underscore SASD and will ignore the underscore TASD. And I restated the BS path again, last bullet point. So the thing we want to do is talk about how you access the tuning adapter diag screens. So if you look at something like list CVT-L, you'll see that the tuning adapter code for type 1520 ends in SIMG, which is a signed image. So that's the newer next generation platform code. And for every single one of those boxes, the Command 2000 access is restricted unless you send that PTEA message to box. Generally send it to all boxes. That's very common practice. I can show you an example of that when we get to that, the demonstration portion. The way is to use a web browser. So you would use like Firefox on the DNCS, or there are ways to set up SSH proxies. And you use a local browser on your PC. So basically the syntax for that is http:// the IP address of the tuning adapter, :5030, which is the street address here, 0.html. And then the navigation bar at the left. So I've documented here in this last graph here that our tuning adapter is in cube 5.1.241. That's modeled cube. The reason it's there is it took work with IT to get one of the ports in that cube access to the TiVo service through the firewall. So it's not impossible with all the fan noise in the lab. We thought moving it in there, but we figured in the end it's just easier to access it in a quieter environment in case you needed to be on the phone with a customer. So just left it there. I noted here also that it has to be connected to the yellow jack in cube 5.1.241 in order to get through the firewall. So if it can't get through the firewall, it can't get to the host service, which is essentially its guide data. And all DVRs are useless without guide data, so the TO wouldn't work. So here are the, take a look at this diag page. This is, in this code, diag 13 of 19. The SDV portion of the diag pages. So there are 7 steps for an SD client, in this case, the embedded SDV client in the tuning adapter, to communicate or to actually register with the SDV server, or SRM. So first of all, it has to be authorized. That means it has to have the SD package. So there are actually 2 ways here. They say a scanless method, which I've shown here, or they can use the auto discovery method. So here what happens is next, the carousel frequencies are known from, for example, the MAS server, or there's a SARA scan list, and so it knows to look at these certain frequencies to find the mini carousel, which it finds because it's on a well-known embedded program number. So once it finds the mini carousel, it reads its service group ID. So it gets mini carousel and reads the service group ID. And the mini carousel we think of as tuning tables for SDV services, which it is, but it also has this basic startup information like service group ID, and C4 is the IP address of its primary and or backup SDV servers. So that's how it gets the IP address of its SD server. So then in step 5, it sends an initialization request, or init rex, to the SDV server. The SDV server will say, hey, I haven't seen that setup before. It'll send an init confirm back to the tuning adapter. It'll do that even if it has seen the tuning adapter before. Like if you reboot the tuning adapter, it's going to do this registration process again because it doesn't store the address of the SDV server or its service group information. So once it gets that init back from the SDV server, bullet point 7 there shows that its server status is ready. So it's registered with the SDV server at that point, and it then consume SD services. One little thing I noted at the bottom of this slide is that with scanless method, a lot of sites, especially Charter, use dummy GQAMs. So I may have heard about that. Just know that there is a dummy GQAM possibility of seeing dummy GQAMs out there.
Is it a requirement?
Actually, no requirement. Let me read this more carefully. I think I dated that, so spare me 1 sec. I did say that backwards. So, I didn't show it here because the normal way to do mini carousel acquisition tuning adapter is the scan list, whether it's a SARA scan list or the one on the Maestro application server. So, but the other way is to reverse steps 2 and 3 and do auto discovery first. So the box would read the service group map file on BFIS and then its service group, and then there are these mini carousel discovery files, one for each, one for each service group ID, and they just have a list of TSIDs and frequencies, and that's how you find the TA would find its initial frequencies to find the mini carousel. So when they did that, these chart sites I'm talking about had big band SDV 100%. They didn't have any Cisco USRMs. That might have changed, but they had to populate the SDV frequencies into their service group map. And to do that, they had to build these dummy GQuam. They would typically offline them to keep QAM Manager and the rest of the Trinity happy. So what happened in the past? So that's the dummy GQuam solution. Now they've gone to the SARA scan list in many cases, or some other third party. I think they may be going to Ovi now. But there would be some way of designating frequencies to look for the mini carousel on. And this is just the next diag page because as you see here, I had step 2 circle around it, died, because it's actually on the next screen that you can see that the mini carousel status is cache ready. So anything besides cache ready, TV is not going to work. There's some other things on here, like kits, cache misses, load failures. Those are all important, but circling everything on the diag screens, what you want to see here is cache ready, and if you don't see cache ready, then you need to look at the rest of the diag screens here. So there is the tuning adapter SDV session information page. There can be session 1 and session 2 would be for like dual tuners and DVRs. Session status. What you want is ready. You see like idle, available. Probably got a screen or a barker that says channel not available. If it's ready, you should have video. There's some other problems, but generally speaking, if you see ready, you've probably got video. You can SAM service /type. You see the SAM service ID /type rather, and so that's useful information to know the not so much the SAM service ID, but you can tell if it's switched or broadcast. And then right below that, you have the source ID, and that's always handy to have the source ID. That would be how you would find your NetCrypt sessions for switch digital video. The page here is Tuning Resolver config file diag page. Now, this was the screenshot that I took on the tuning adapter that's in my old cube, the one that's mentioned in this presentation. And we use the SARA app server. And since you don't need a TR config file with a SARA app server, and engineering never implemented this optional feature on the SARA app server, we don't have one. So there are no TR config files on any of our labs. So we see tconfig file here, last load time, or load time in A, and we don't have config files. And this page here is called UDCP. Remember, that's the unidirectional digital cable product, which is generally a TiVo. So that's where it says UDCP connected. That's obviously means that the TiVo is connected to the tuning adapter. So you see that. And then authorized, yes, that means that the TiVo is authorized. It does not mean that the TA is authorized. There's another page for that. We'll just take a quick look at some of the ways to access the diags. I'll have one slide to come back to after that. So this is the 104 DNCS in our lab. And type in, let's see, didn't write down the MAC address. Let me see if it's in the history. Okay. I was trying to get a font size that was a little bigger for viewing, but it gaps on this resolution here. So, and it's just your standard tel DHCT-H space MAC address. And I see that this is a model 1520, which is the type of the STA1520 Tuning Adapter, and its IP address is 10.1.0.238. So I open up a Firefox on the DNCS, and I put in the URL that I documented in the presentation. So the IP address of the tuning adapter. 5030. Do individual diag pages, but to bring up, a page with should be the first diag page and then a navigation bar to the other diag pages on the left-hand side. Just put in 0.html. There it goes. So actually, it brings up all of the diags. You can then scroll through those diag pages like that. But I'll notice that they're linked to the individual diag pages here. Like if you just wanted to, I think Tuning Resolver is the one where you would see the TR config file. Got it. Yeah. But in our lab, we don't have a TA config file. So you can access all those that way. A lot of times, Command 1000 is more convenient for cutting and pasting into case notes, but you do have the disadvantage of needing to send a PTA message to this next generation platform box, the tuning adapter. But it can easily be done. Most sites have that set up on their DNCS now, so what will happen is our lab, it's in just DNCS bin. It could actually be anywhere. A lot of times it's in the utilities directory. So let me just do an ls here. So this increased or this low resolution doesn't look as nice as I was hoping. This is the syntea.pl script. And a message file that is typically called ptea msg. It doesn't really have to be that. It could be and.txt if you wanted to do, put your name or whatever. You could call it anything. There is a ptea.msg here. Let's make that. Alright, what you have in here is a version number, and the documentation says that you have to increase the version number every time you send a PTEA message. I do not find that to be true in our lab. I left this with version 0 for months and months, and every time I need to ask Command 2000 with our tuning adapter, choose the same tuning adapter or PTEA.message file. And notice, also the documentation says that the values go from 0 to 255. So obviously you would be able to send 256 messages, and that just doesn't make any sense. Empirically in my lab, it doesn't work that way. you don't have to increment the version number. There is a global section, which means that you're going to send this pass-through message. PTA, I know PT stands for pass-through, and EA, I believe, stands for entitlement agent or something like that. What I'm trying to do is turn on certain functionality secured by default on the tuning adapter. And in this case, we want to enable T2K or Command 2000 for a certain duration, 0 meaning forever. I left in here because it's in the documentation. You can enable Telnet. I've been given a list of commands that are supported that would be useful. All you want to do is look at your, either with your Firefox browser on the DNDS or with Command 2000, you just want to look at diags that are available to you, because you need to find out if the TA is authorized. You need to find out if it's registered with its SDV server. You need to find out if it's connected properly to its Evo. And it's a non-Sarah site. You need to see if it's received its TR config file, which is a channel map from the third-party application server. So that's about it. So there really, even if there might be some neat developer commands, if we could telnet to it, yeah, but they've never provided us with those commands. So what we need then is to send pass-through message this syntax. So if you scroll back through here, basically all you're going to see is a bunch of X and the fact that we're enabling Command 2000 right there, and Telnet, which we really care about. I just left it in there in our lab in case I ever needed it. So I could look at the message file, PTEA message file in our lab, and say, yeah, that's the syntax for it.
Dan, can you go up again just to get my command?
Yeah. Send ptea.pl, whatever the message file name. It could be anything. It could be kevin.txt. So most people call it ptea.msg. The thing about the global, I guess I didn't really cover that as well as I should have. So that's a good point. Let's see here. Like this message file again. There's a global section, and there is, and this commented out, this is the group section. This would be the addressable section. For example, I want to only send the pass-through message to this address. I mean, if I'm doing it this way because I found that I have to increment the version number. I really think it's useful to waste time editing the file and putting in a MAC address. When a global pass-through message, they always say, well, what's the impact of that? There's no impact. Boxes get pass-through messages all the time. So, I actually had customers say, well, we don't do that. We don't want a pass-through message that we don't know the impact of. But you have the Firefox browser, you could use that. Sometimes you might encounter, who is unwilling to send this pass-through message, but I've never heard of this message causing a problem with tuning adapters or any other box out there. So that really brings us to the summary, and any other questions. So, remember that the tuning adapter spec from Cable Labs still calls it a tuning resolver, hence the name trconfig file, but all people say TA config file. I saw on that diag screen it said tuning resolver at the top, and then it said TA config file on the left. And if you look on BFIS, the file is actually called trconfig.tbl. So even our own diag pages are inconsistent with the use of that term. The Cisco tuning adapter is a Sarah box, and it runs Sarah code. But in the absence of a Sarah app server, you need a trconfig file, which is generated by a third-party application server like the application server from AGG. They publish these trconfig files on BFIS. Generally, there's one trconfig file per hub, in one channel map per hub. But you can use a single default channel map. So if the only trconfig.tbl file is 0. Under the 0 directory, and let's see, where would that be actually? There we go. So the BFIS URL is always msoconfig SDV and the ID. So hub 0 would be your default channel map. trconfig.tbl. Now the absolute path, as I said, actually exists on the DNCS in a couple of places, or they could really put it wherever they want. You could do a find on it and get it that way. So it says, well, the config file is not Rovi's responsibility. It's Cisco's responsibility. It's not Cisco's responsibility because we implemented config files in our solution. So even if they had an app server, a SAP server, there's a config file, they would have to run SManager, which would be the normal way if you have a Sarah app server. So you have to just get the third-party vendor on the phone, Rovi or ATG. Sometimes you're talking to somebody who's not very familiar with the tuning adapter and they don't know what the trconfig file is. Well, try to get them to ping somebody else. ATG especially is very good at realizing that regenerate and publish that trconfig file on BFIS when they add channels. So the guy who actually built the channel might not have been aware of that, because I built this channel. It's working on my MDN and ODN boxes, but my adapters aren't getting it. TiVos can't get it. So what's wrong? They forgot to publish the trconfig file from the Maestro application server on BFIS. So subscription packages go on the cable card in the TiVo, stuff HBO, or subscription, right? The card would also need a brick package if that uses a brick package, but does not need the SDV package because the cable card is in a one-way device. UDCT means the unidirectional part means it's a one-way device. So even though the cable card is capable of two-way and getting an IP address, when it's in a TiVo, it's a one-way host, so they generally don't even put it as two-way. They're usually in service one-way. So you don't need the SDV package on the cable card in the TiVo. You need package and all your subscription packages. The TA, however, does any subscription packages. It just needs a brick package and an SDV package. Authorize it for SDV, and of course the package just authorizes it, period, for anything at all. For the brick package just prevents it from being service, right? So, the last thing I wanted to read here was that with a tuning adapter connected to a TiVo, the map no longer comes from the cable card, but from the tuning adapter. I thought it was an important point, and that's really the end of what I prepared. So, any questions? Okay, so Mike has seen. I think I sit with a TiVo Lab. There are QAM cards out there that will go in PCs, and they are considered UDCPs. So when we're used to saying TiVo, there are other brands out there. So it's been seen by me and Mike. So there'll be more coming. So point. Yeah. It's just everybody knows about TiVos and tuning adapters, and so the UDCP, it's kind of cumbersome. So I just generally say TiVo. So I guess if no further questions or anything you'd like to see, we'll just wrap it. Anything else, guys?
Thank you, Dan.
All right. Thanks.